The objective in this lesson is to generate formulas to determine the area and perimeter of a rectangle and to be able to explain our reasoning. In this lesson, students will reflect on the processes they use to find the area and perimeter of a rectangle. As they reflect on their thinking, they will understand and make connections to the abstract formula. They will be able to create situational equations using reasoning. Students should not use the formulas as a plug-and-go tool. Area is the inside measure within a two-dimensional plane shape. Area is expressed in square units. Perimeter is the border or boundary of a two-dimensional shape. Let's determine the area of this rectangle. There are many ways we could calculate the area. First, we could count each square. By counting, we get the area of 48 square units. Repeated addition is also a strategy. We recognize that there are 8 squares in each row and we have 6 rows. Therefore, 8 plus 8 plus 8 plus 8 plus 8 plus 8 equals 48. Another strategy is decomposing the rectangle into pieces. We can divide it into a 5 unit by 8 unit and a 1 unit by 8 unit. We know that 5 times 8 is 40, and then we need to add the last group of 8 to get 48. Finally, another strategy is to use multiplication. We recognize that the rectangle makes an array. The array is 6 by 8. 6 times 8 equals 48. Let's examine what we use to figure out the area of this rectangle. Examining our thinking will help us write a rule to find the area of the rectangle every time. We noticed that when we used repeated addition, we had 6 groups of 8, or 6 times 8. We also noticed when we used multiplication, we multiplied 6 times 8, or we multiplied the width times the length. The area is the width times the length of the rectangle. The variable for area is A. L times W equals A. Length times width equals area. Now let's determine the perimeter of the 6 unit by 8 unit rectangle. Looking at the rectangle, we can count the outside units. We will mark our starting spot and count around the edge. This will take some time and we should mark each edge piece to avoid losing our spot. We might figure out the length of each side and then add each side together. 6 units plus 8 units plus 6 units plus 8 units equals a perimeter of 28 units. Another strategy is to recognize that the opposite sides of this rectangle are equal. So once we determine that one side is 6 units, we know the opposite side is also 6 units. Since this side is 8 units, the opposite side is also 8 units. 6 plus 6 plus 8 plus 8 equals 28. We recognize that we use the length 2 times and the width 2 times. So our rule could be length plus width plus width. Since there are 2 lengths and 2 widths, we could say 2 lengths or 2L and 2 widths or 2W. So our rule or equation is 2L plus 2W, which equals P, where P is the variable for perimeter. The Jones family is creating a garden. The dimensions will be 48 inches wide and 96 inches long. Since they have a dog, they will need to fence it in. How much fencing do they need? Also, how much grass will they need to remove? We have 2 problems to figure out. Let's draw and label a picture to help us. The dimensions of the garden are 48 inches by 96 inches. We know that the fence will go around the outside or the perimeter of the garden. Since we have labeled our picture, we can see the perimeter will be 2 times 48 plus 2 times 96 and get 288 inches. Next, they are removing the grass. To figure out how much grass they will remove, we need to figure out the area. We know that since the garden is a rectangle, we have 48 groups of 96 inches, or 48 times 96. If we multiply 48 times 96, we will determine how much grass the Joneses are removing. We could use the partial product or open array models to solve this problem. Let's use open array. First, we will draw our array and then label it. On the left side, write 40 plus 8, and across the top, we will write 90 plus 6. Let's solve by using partial products. 40 times 90 equals 3,600. 40 times 6 equals 240. 8 times 90 equals 720, and 8 times 6 equals 48. Let's sum up our partial products to determine the area. The Joneses will be removing 4,608 square inches of grass to create their garden. The objective for this lesson was to generate formulas to determine the area and perimeter of a rectangle and be able to explain our reasoning. We met this objective by understanding area and perimeter and applying this knowledge as we examine the processes we used to calculate each. We did not memorize or use the formulas as a plug-in tool.